For the last hard rate structure that will be discussed in this topic, known as energy dissipator structure. Energy dissipator structure is a not common structure where you can see like sluice gate, weir, or bridges. Energy dissipator normally located at the bottom of the dam, and this structure commonly built to reduce the kinetic energy of the flow. In the simple word, energy dissipator try to dissipate the energy of the power of the water that flow from the upstream to the downstream to reduce the power of the flow. And by reducing the energy of the power, we can reduce the impact to the downstream. When designing an energy dissipator for a specific location, so there are several factors must be considered, such as site location, the type of energy dissipator, discharge to the dissipator, and in this topic, we will be discussing on USBR Stirling Basin Type 3. The bottom figure shows the modeling or how the energy dissipator structure has been used to reduce the power or energy of kinetic energy of the flow to the downstream. If you can see, the various color on the modeling shows that the power at the upstream has been reduced to the downstream. For USBR, USBR stands for US Department of Interior Bureau of Reclamation. For Stirling Basin that will be discussed in this topic will be based on USBR 1984, published by US Department of the Interior Bureau of Reclamation. So based on this document, there are 10 types of Stirling Basin. If you can see in this figure, there is type 1 and type 2, type 3, type 4, 5, 6, 7, 8, 9, and lastly 10. So here the photos, the example of USBR Stirling Basin type 3, because in this topic we'll be focusing on this type only. So next is the calculation of USBR Stirling Basin type 3. For this structure, there are 3 sets of blocks, as you can see in the figure. The first one known as Block A or chute block, Block B known as bumper field, and the Block C known as end seal. Okay. If you look to this figure, there are several parameters that must be considered. The first one is here, S represent the width between the block, W represent the width of the block, and H is the height of the block, and followed by the block B. So the value for S, W, and H is as I mentioned earlier. And for the last, for block C, we have to identify H4. So in this topic, I will share on how we can determine the number of blocks that must be built for block A, block B, and block C. So the calculation can be summarized in this table. So for block A, there are 3 parameters that have to be calculated, while for block B, there are 5 values that must be calculated. And the last one is for block C, only H4 and Z4. For Z is the side slope. If you can see in this figure, so Z3 is represent the side slope of the block B, while for the Z4 represent the value of the side slope for block C. As I shown earlier in this table, to start the calculation or to determine the value of this parameter, several parameters must be identified. For example, in this case, in this figure, we can see we must know the height of H0 and H1. H0 is the height of the water before it's flowing down to the downstream, while for H1 is the height of the water from the top to the bottom of the Stellium basin. And in this figure as well, we can find the value of Y1 and Y2. And all this value will be utilized or used in this table in order to determine the value of H1, S1 and W1, and follows by another parameter. This graph will be used in order to determine the length of the basin. I mean here, if you look on the y-axis, the value of L. So how we can use this figure? We have to determine the value of Froude number in the first hand. This graph shows how the value of L being measured. The L is represent the length of basin. So in order to determine the value of L, the value of Froude number must be calculated. So the Froude number can be calculated based on this equation. So once we have the value of Froude number, we have to project it to the line and project it to the y-axis to determine the L value. This slide shows the summary of steps that involve in determining the size of USBR Stellium basin type 3. And in this slide, I summarize step by step of determining the size from step 1 until step 5. You can follow this step if you forget what I have mentioned earlier.